You have a tough act to follow now with the London crowd. They took me out to a pub afterwards, and it was a lot of fun. Okay, so I'm thinking this Grasshopper right across the street will do. So maybe we'll get some beers or something afterwards. So, but anyway, thanks for coming, especially on a Sunday where you got beautiful weather like this. And so I do appreciate you making the effort to come out. We got some really great content to cover. A little bit more about myself. I'm the technical evangelist, like Brigitte said, and I am also I was also a Microsoft MVP and most valuable professional for a few years. I actually worked for Microsoft too for about a dozen years in a developer evangelist role as well. Last year I authored a book on Azure and Xamarin Forms by publisher A-Press. And then also I'm a publisher of several apps, including the endorsed Jethro Tull app. I know Jethro Tull makes frequent stops here to Amsterdam, so hopefully anybody not know who that is? If you don't know, ask your parents. They'll fill you in on that one. But I especially had to show that in London because their office is like right around the corner there. You know, I actually asked them if they wanted to attend the blockchain session because that's a good, market, right, for musicians using blockchain to keep their digital rights and all their assets, protected. So, but they couldn't show up. They were setting up for a festival or something like that, so they couldn't come. Anyway, that's a little bit about myself. Also, we got Algorand, right? So our theme, our motto is borderless economy, boundless opportunity, and Algorand is defining the standard for blockchain technology, and I truly believe that. And we'll go into some of the cool things that we got going on with the Algorand technology. Before I get going, you get the goods here. So the deck I put up on this bit.ly, it's actually SlideShare URL, so if you want to take a picture of that, you can. All the code I'm going to be showing you is from our GitHub, Algorand GitHub. So you'll have access to all the code, and then the deck with some really good links in it for resources. And I think blockchain has a lot of promise. Anybody need that on there anymore? Good in that? Okay. So who here is excited about the blockchain promise? Show of hands. Yeah, a good number of you. That's great. Who here is fairly new to blockchain? A few of you as well. All right, very good. So really what we're talking about is, unlimited applications. And has anybody actually built any solutions here for other blockchains? Okay. How many are developers? About half of you. That's good. All right. And what languages do y'all use?
Go in.
Go. All right.
Java.
All right. What was that?
Java.
Java. Okay.
C#.
C#, baby. Who's that? Oh, you're my man. Okay.
No bias.
That's it. I'll buy you a beer, all right? First one to get the beer over there. So the blockchain promise, right? For a few years, developers have had a hunch, that this is the right technology. And the blockchain holds the key to more efficient and more inclusive financial systems. And in simple terms, the blockchain is a public ledger, right? And in programmer terms, it's a distributed database that's write once and read only. And every node in the network has access to, you got the database, and it's a sequence of transactions organized in blocks and guaranteeing three fundamental properties. Number one, everyone can read every block, so the blocks become common knowledge, right? And everybody can write a transaction in a future block, and no one can alter the transactions in a block on the order of the block. So, it's tamper-proof because it's an immutable ledger, and it's transparency because all the transactions are public, and there is trust. No one can alter it. So rather than, having hidden databases, kept by central authorities, as like banks have, and rather than having, transactions pass through layers of, secret databases in order to clear, we can have a single public ledger that can be read by everybody, in which everybody can write, but nobody can alter, like I said. So what's been happening to hidden databases kept by the central authority? Well, let's take a look at that. This is actually a video clip I'm going to show you, and I was eating dinner in my, with my TV tray and watching TV, and this came up on the local news. And I said, man, I got to get this. So I got my iPhone out right away. So that's the recording from my living room, or on my TV. And I think it really summarizes what's been going on with a lot of the, recent ransomware things. So anyway, just let me play it.
Go like ransomware, freezing thousands of city computers. Hackers demanded 13 bitcoins worth about $100,000 for the code to unlock the system. A similar attack tied Atlanta in knots last year and cost millions to recover. Greenville, North Carolina, a city of 90,000, was hit just last month. So far this year, analysts say 25 local governments have been victimized.
Isn't that crazy?
The president of Baltimore City Council, Brandon Scott, says his city will not pay the ransom.
When you talk to technology people and others that people will pay ransoms, they can leave something in the system and come back and shut you down again. And I just have to take the advice of the law enforcement and the professionals.
Cybersecurity experts say the spread of these attacks is a warning that cities large and small must be better prepared.
Cash-strapped municipalities are uniquely vulnerable to this kind of ransomware attack because they're using older systems, they don't keep them updated, and they don't have the resources to be able to respond.
But with ransomware attacks spreading, cities are finding that a strong defense is no longer a luxury. Lester?
Hey, Williams in Baltimore, that
Go like ransom.
So that is, what do you think of that clip? But very timely, right? This is something that I think we're seeing a lot of these days. It's almost a every day you hear about this now. And even the next night in the news, there was something about, the Florida looking at the, our voting system, right? And making that more foolproof. Again, another great blockchain application with the immutable ledger and having the votes only count once and all that kind of stuff. So I think, it goes further, right? Among the millennials, 90% or 92% do not trust banks. And that's a pretty serious dent. And not only is it slow in terms of response time sometimes for transactions, but we got $5 trillion are wasted every year on transaction fees of all types. And a couple billion people around the world lack access to modern financial services altogether because the banks find it simply too small and to be profitable, right, for them to try to make that happen. So this is where we're at, and so what we're going to talk about over the next hour is what is Algorand, our consensus model. Then we get into a lot of developer stuff. So we got the testnet process architecture. We're going to go through some of the APIs and actual code as well, SDKs and our command line tools, and we'll end with some planned developer features. So what is Algorand? First of all, our vision is to solve these problems like we've been talking about, to give the world a borderless economy. Commerce, transaction, participation, or complete digital lives can be migrated to the platform ready for the new millennia. And you can see right there we've got the pure proof of stake blockchain. I'm going to go into more on that, as well as permissionless. We got fans, very fast transaction throughput and finality, no forking, and upgrades on the chain in place. And there's really great man right at the top of our organization, Silvio Michele. He is the founder of Algorand. He's also a winner of the Turing Award. So for anybody who's not familiar with the Turing Award, it's kind of like the Grammy in entertainment, but this is in the computing field. So I feel very humbled, right, to work at this organization, having a genius like that, at the top. And a lot of the smarts he has, he really put into the product. We're going to go over a few of these right now with our proof of stake, and there's actually a link on the construct section there for the borderless economy. If you go out to the, it was done at the consensus keynote a week or two ago. So I recommend taking a look at that. And also we have a lot of great videos at our YouTube channel. So we're going to be open sourcing all of our code when it becomes final, sometime this month actually, in June. So we're really right around the corner. So every token has the same power, easy online participation, optionally offline, incentives to participate in the way of renewals, on or offline, and fast transaction throughput with consensus in seconds without soft forks on a strong and secure network. And I was talking to a few of you down in the lobby about this with the, the blockchain trilemma. And it's really, sustained by evidence with over 2,000 blockchain projects so far. The trilemma essentially states that existing blockchains can offer at most two of the following three properties: security, scalability, and decentralization. So without decentralization, of course, we kind of stay where we're at with these financial systems already in place today that are exclusive and secretive, and apparently prone to hacks as well, right? Without security, blockchain transactions can vanish, and so you may have transactions that could be tampered with and by adversaries to their own benefit. And without scalability, of course, you only create solutions for small networks, not global-wide networks. So you really need scalability. So nobody should have to be, settle for two of those. So that's kind of the what, but how about the how? Well, first of all blocks have one-way hashes, right, tying them together, and all blockchains share this approach, including Algorand. But the second need is generating new blocks, right? And this is where the trilemma problems have come in. Let's take a quick look at a few of these alternatives. Proof of work, delegated proof of stake, bonded proof of stake, and all of these approaches have a fatal flaw. And this quote is really from an article by Silvio recently where he says that the whole economy is at the mercy of a small part of the economy. And that is it in a nutshell, and hopefully you'll understand this a little bit more as I go through these. So let's drill down into each one of these a little bit. So in proof of work, a small part of the economy is owned by the miners, and since the miners own only a small fraction of the money of a proof of work blockchain, it's not secure. And there are really only 3 mining pools out there, so an adversary may attack either the protocol by sending messages that are different than the prescribed ones, or the communication network itself, and interfering with routers and cables, etc. Right? So a side effect of proof of work is forking, and this can cause scalability issues, and it's not very green either, as massive amounts of energy are required for mining. On the proof of stake, another approach is delegated proof of stake, and here the community empowers a few special users known as delegates and to choose the next block. Therefore, it's centralized right from the get-go, when you think about that kind of an approach. Denial of service attacks are quite cheap and can be mounted instantly against delegates. And since delegates are known, a determined adversary can bring down the delegates by a fast denial of service attack. And then we got bonded proof of stake. So bonded proof of stake allows 20 users, 200 users, as many that are willing to put some money on the table, a bond, and where they can no longer touch it. And these are the users who select the next block on behalf of all of us. If they misbehave, their money is confiscated. But bonded proof of stake, therefore, not only makes it possible, but makes it easy for big thieves with deep pockets to put in a disproportionate amount of money on the table for the sole purpose of controlling the blockchain. And even if they put in like a couple million, there's trillions of dollars worth of activity in networks. So that's really, it may seem like it's a lot, couple million, but if your plans are bigger and more devious, there's a lot more to get out of it from that. And then we get to Algorand logic and proof of stake. So essentially a proof of stake, pure proof of stake, does not try to keep users honest, right, by the fear of imposing fines. Rather, it makes cheating by the minority of the money impossible, and cheating by the majority of the money just plain stupid. And I'll explain why. Algorand's logic is simple. It ties the security of the whole economy and honesty of the majority to the economy. It makes it possible for a small subset of the economy to control the fate of the whole economy. So in Algorand, only the owners of the majority of the money could prevent other users from transacting. But if they did so, the reputation and currency would be greatly harmed when you think about it, right? So the currency would no longer universally accepted, and its purchasing power would be greatly diminished. And it's not a good outcome for the owners of the majority of the money. So there's really not an incentive there to disrupt that. At a very high level, Algorand new block is constructed in 2 phases. The first phase, single token is randomly selected, and its owner is the user who proposes the next block. So a token is a coin, is the way you can think of that. If whoever got a coin will go ahead and propose the first block randomly. And then in the second phase, 1,000 tokens are selected among all the tokens currently in the system, and the owners of these 1,000 tokens are selected to be part of a phase 2 committee, which approves the block proposed by the first user. And so when defeating the trilemma now with Algorand, it's secure, right? You got committee members that are not known until after the fact, and that's a very important thing, because that's what provides a vulnerability on some of the other systems that we talked about, is they know who those folks are, and here they don't. So that's really good from a secure standpoint, and everything is cryptographically signed. It scales, right? You got minimal amount of message going on, a lot of re-execution, extremely fast, so it's all math. And decentralized, low barrier to entry, and anyone can participate in the consensus. So the last several slides I derived from this article called Algorand's Core Technology in a Nutshell. Anybody read that article at all? I highly recommend you go out to our blog. It's by Silvio. It was recently posted 2 or 3 weeks ago. And it's about a 20-minute read, so I recommend that as your homework assignment after you get done with your holiday today, right, this weekend. So that's a good read. Any questions so far?
What does the token do? The token, you get paid for consensus?
Yeah, you do. So the monetary aspects, right, you're looking at. So we do have, I'm going to talk about this a little bit more, but we do have the Algorand Foundation that is really in charge of the money side of the house. Okay, I work for Algorand Inc., and we're responsible for the technology side of Algorand. And I will go into that in a little bit in a few slides, okay? Byzantine agreement. Who here is familiar with that? And few of you are, kind of. I think the way it goes, you had these generals way back in that era, and there was a, good number of them, 4 to 20. I can't remember how the story goes, but there's a good number, and they got to communicate via a messenger. And the good part is, they have to come up with a decision here on whether to attack or to retreat. And so the best case is all of the messengers make it to all the generals, and they're all, legit. They don't get corrupted by thieves, or weather doesn't stop them, or whatever. Right? There's a lot of possibilities there in terms of whether the message is successfully delivered. So if all of them get there, and then they got all the information they need to make a decision. Yeah, everybody's supplied, we're ready to go, let's attack. The worst case is, of course, if only half of them really get back with accurate messaging, then it's a false assumption, right? There is what you're doing, and then if you're doing an attack and half the generals don't have the supplies, you're going to fail. And that's really the whole thing behind that. And the thing is that doesn't scale either. This particular agreement only works up to 21 people, I think, something like that. And after that, really, what you want to look at is a function of, how well something scales versus the cost. And I was actually talking to one of our mathematicians there, and he provided me some insight on isotonic computational complexity, right, which is exactly that, the study of scale versus cost. And linear, would be like double the people, you're going to double the cost. And then it gets into some quadratic type functions where, maybe 10 times will result in 100 times the cost, or even worse, 1 million people would be like 1 million squared. So it really gets out of control very quickly. So Silvio figured it out. You don't really want everyone don't need everyone to participate. What you need is a representative sample. And the sample will vote, and then it'll be a representative to grab a uniform. It's just called our verifiable random function, the VRF. And we have this open source right now. And so you mix that with the Byzantine agreement algorithm, and you end up with a scalable agreement on how transactions are processed. So it's green, and it's very efficient, and there's not a whole lot of overhead like there is on mining blocks to create the next blocks. So that's kind of at a high level there. What we're talking about, a little bit more deeper here in terms of the Algorand consensus. Basically, one account is chosen to propose a block. The committee chosen to vote, soft vote on the